Hello everyone, my name is 𝐕𝐳𝐬𝐴 and in this video we are going to look at the solution of the problem increasing array, and this problem can be found on the CSES problem set and the introductory problem sections. And this is a very easy problem, but we are covering it for the sake of covering it because this particular video is part of our greedy series. The particular course I am putting on YouTube, in which we are studying greedy algorithms, in which we are doing I'm going to cover all the problems from the very basic to advanced. And if you are new to the channel, please do subscribe and share it with your friends. And let's look at this particular problem and discuss how we can solve these types of problems, and how we can build our intuition towards the greedy type of problems, how we can solve the greedy type of problems. Let's discuss this. And so what is being asked in this problem is, you are given an array of n integers. You want to modify the array so that it is increasing, that is, every element is at least as large as the previous element. So we have to create an array which is non-decreasing. We can say it as non-decreasing or an increasing array, in which every element is greater than or equals to the previous element, like the previous element. For example, if the a of I element should be greater than or equals to the a of I minus 1 element, the ith element should be greater than or equals to the I minus 1th element. That's the simple definition of a non-decreasing array or the increasing array. We have to build the particular array using this, and to do this particular thing we have one type of operation. What is this operation? In this particular operation, or in this particular move, on each move you may increase the value of an element by 1. For example, if a of I is equals to 10, then with one move you can increase it by 11. Like, you can increase its value by +1. You can't decrease any value, you just can increase the particular value of an array, and you have to tell what are the minimum number of moves required to make the particular array non-decreasing or increasing. So that, the problem statement is very simple, and the solution is also very simple, but we are going to cover it. So in the input section we are given that n, which will depict as the size of the array, and then we are given the array elements, which are x1, x2, x3 up to and so on xn. These are the array elements we are given, and for each test case, for each input, we have to print the minimum number of moves to make the particular array non-decreasing. That's our problem statement. And if you look at the constraints, n goes from 10, is maximum n value is 2 times 10 to the power 5. So we have to discuss a fast algorithm of O n log n, or O of n. N square solution will not work with these constraints, so we have to find an efficient algorithm to solve this. And xi values is 10 to the power 9, so we are not worried about this. And the input is 532,517. Let's just discuss one example. In this example we are given 32517, and as you can see, let me just give them indexes also. We are using zero based indexing here, and as you can see, the first index, the first element, with respect to the zero based indexing schema, a of 1 is less than a of 0, and this makes it a non-decreasing. This does not make it a non-decreasing array. We want a of 1 to be greater than a of 0. So what we can do is we can add +1, because we have to take the minimum number of steps, and taking the minimum number of steps we have to make it the non-decreasing array. So we will just increase its value by 1 +1, and then we have 5 is also greater than 3. This value will become 3 at the last, and 5 is already greater than, but 1 is not greater than, so we will add 4 and make it 5, because we only need to make the minimum number of moves, and 7 is already greater than this. So how many moves we made? We made 5 moves. In 2 we added a 1 and made it 3, and with 1 we added 4 and made it 5. So how many minimum number of moves we made? We made just 5 minimum number of steps. So with this particular example, you are you already know the answer. How am I going to solve this particular problem? The problem statement is very simple. If we think about the greedy approach, what does the greedy approach says to us? What are the basic definition of the greedy? Greedy says us to make the best move at that particular moment. So Grady says us that make that particular move which is the best at that particular moment. So when we are at 3, so this is the first element, we are not worried about this. When we went to the 2, so what is the most simple solution to this is like if we calculate the difference. I'm like depicting the difference with delta, and you like delta is simply a of I minus a of I minus 1, and simply like a of I minus 1 minus a of I. Since a of I is greater than, so I am taking the positive value here. So the delta here is simply 1. So that delta says us that a of I is less than a of I minus 1 by 1. This is a simple thing. So what we can do is we can just add 1 to this particular like the array element, and we can make it equal to the previous element. We are not making them greater to the previous element because we want to make the minimum number of steps. So what we can do is we will add the delta to our number of moves and we will make it equal to this. So what we can do is simply if array of I is less than array of I minus 1, then what we can do is we will create delta. What is the value of delta here is array of I minus 1 minus array of I, and we will add that particular delta to our result. What is the result? Like how many minimum number of moves we are making, and then we can just increase this particular value to array of I minus 1. We will make them equal. We are not making it greater than that because we need the minimum number of moves. We are just like increasing it step by step. We are just increasing it by delta. So like you already get the answer why we add the result like the delta to our result, because these are the moves we have to make. Like these are there's no alternative way to solve this particular problem, because like the difference is there. If the array of I minus 1 is like 7 and array of I is simply like 3, so we have to add 4 minimum. We have to add 4 to this to make it equal to this array of I minus 1, to make it non-decreasing. We made it 7, and if for example I plus 1 is again 2, we have to add 5 to make it equal to 7. So these are the minimum number of steps we have to make. So we are calculating delta, which is array of I minus array of I minus 1, and making them will give us like how many number of steps we have to make it like non-decreasing. And we have to like also do this particular step to make it equal to that. We are just like making it equal to that particular element, and that is how we can solve this problem. So simply the algorithm will be for I. We go to 1 to n, and for that for each element we will check if the particular element is greater than or less than the previous element. If it is less than the previous element, we will calculate delta and we will like add it to our result. What is the delta? Delta signifies us what are the minimum number of steps we have to make to reach to that particular definition, and then we will just simply say like make array of I equals to array of I minus 1, because we are just making them equal. We are not making them greater than or something like that. We are just making them equal to this particular element. So the problem is fairly simple, but we have to like cover these types of problems. These are the problems that build up our confidence, and we have to like start always from the very basic problems. That's how you should grow, and that's how you should be doing everything. And I hope you like get the idea of this particular problem. Also, there is one alternate solution to this. Is I want you to like do it yourself, in which we maintain the current max. What does I mean by this is like if we have the particular array, we will just maintain the current max and make our particular element equal to that particular max. Like our current max is currently equals to 3. We went to 2 and the current max is 3. We will calculate delta, we will make it plus 1, and then our current max becomes 3. Then we went to 5. We update our current max to 5. Like the previous element in the previous like the suffix of the array, what is the maximum element, and we will make all the particular elements equal to that. Like we will make a of I equal to that particular maximum. Like a very simple like just another way of looking at the problem, but the solution we discussed above is a very fairly like simple problem. Also, if you guys are like following the series from the very first video, we also discuss about invariant and monovariants. What do we mean by invariants and monovariants? We use these particular mathematical terms to prove our greedy solutions. So this is a very fairly simple problem, and you can see the invariant here is like the array should be always non-decreasing, meaning the array should be always increasing by making every possible move. That's the particular definition of the invariant to prove our greedy solution is correct, and that particular statement, like the condition says us like the array element should always be non-decreasing. So that condition is going to be always true before the array, after the array, of the partial solution. All the steps we make, we will keep this particular condition true, so that we prove the invariant is also there. And with the monovariants, we are always increasing our result by delta. So we are always doing array of I minus 1 minus array of I, and we are adding that to our particular solution, so that we are moving towards the termination of our algorithm, which is also we are like moving towards this is considered as the progress of our particular problem. I know like we don't need to prove these particular algorithm, these are very simple using the invariants and monovariants, but I taught you these things, so I just mentioned them here. So let's just discuss about the code of this problem, and the code is fairly simple. Code is like the same I already discussed with you above. We will use C++, you can use Java and Python fairly simply. So we use constant headers and all. Our main function start, we use fast input output, and if you guys are like following my channel, I use this particular template like always. Like this is the very simple template, I use it everywhere. If you guys want, you can, otherwise you can see like people use very complex templates, but I like this very simple. We will read in n, we will read the value of n because the input says so, and we will then read our vector. We will read our array, like the vector or array, then we will like define our result, and we will calculate the delta, which is simply like we start with I equals to 1 to I minus 1. We are not starting from 0, because like if we start from 0, we will get an array of index of out of bounds. So it's you can get that, and we will start with I equals to 1 and I is less than n plus I, and if array of I is less than array of I minus 1, like the current element is less than the previous element, so we will add that particular to our results, that particular delta to our result, and then we will make the array of I equals to the array of I minus 1, and we will like finally return the value of the result. You can see the time complexity of this particular problem is O of n, and the space complexity is O of 1, because we are not using any extra space. The array is already given to us and the variables are not counted, so we are not using any extra space. So the time complexity of 1 and the space complexity is O1. So this is the particular solution of this is the solution of this particular problem. I know this is a simple problem, but you have to do like these problems also. And with this, like if you guys like the particular solution, please hit like the like button and share it with your friends. Subscribe to the channel, and please do comment if you are enjoying the series, if you want me to cover anything else, if you want me to cover any questions in this particular series. So please do comment in, please do share it with your friends, subscribe and like the video also. And that's it for this video, and have a nice day. See you in the next video.